process of referring to the material that we have covered. So, like I was explaining, this course will give an understanding of what software testing and quality assurance is all about, meaning that there will be an emphasis on these two concepts. One of them being what is software testing, and the other one is quality assurance. And those are the two things we are going to look at as we introduce. But by the end of this course, or at the end of this class, you will be required to understand what are the practices which normally support the production of a quality software. So that is one of the expectations which will be there. You will also be required to understand what are the different software testing techniques which are normally used when testing software. Another goal is to enable you as a student to understand the life cycle models which are used for checking for requirements, also checking for defects, test cases, and the test results. How you can be able to use those different models to get what is expected. And then we will also make sure that as you finish this course, you understand the process of modeling of units, integration, the system itself, acceptance testing, and quality models, which are normally used. We will also make sure that you can demonstrate or you can show understanding in managing a software project. When a customer has given you the requirements, then you can be able to manage that software project from start to completion and deliver a quality software. And then we will be looking at these different standards which are normally used for software quality assurance, like the ISO 9000, the capability maturity model, and many others. So by the end of this course, those are some of the things you will be able to have acquired. And the goal of this course is to ensure that you will have gotten that. Now, just to briefly try to understand, when we are talking about software, what exactly does it mean? Yes, Mary?
Question.
Yes.
On the recording.
Yes.
Only you that can record, or can we also record the meeting?
No, it is normally, even when you start the recording, it will be delivered to me, the person who initiated the meeting, and then I can share it with you.
Oh, okay. You can go on.
Yes. Okay. Thank you.
Okay.
I will also request that you can mute your microphones so that at least there is no echo, and then we can have the class. Whenever you have a question, when you raise your hand, I will be able to see. Thank you. So when we are trying to understand what is software, we normally say software is a series of those instructions which tell the hardware what to do, or the computer hardware what it needs to do. And when we are coming to the software itself, when we are talking about software testing, it is because software testing is important. It needs to be checked. It needs to be evaluated from time to time so that you can be able to know that it has the intended behavior or it has the required functionality, so that at the end of each development stage, you are able to know that it has delivered what is expected. If, for example, you had said, I need to have a software for recording student marks, then when you start by accomplishing this requirement of recording student marks, you need to be able, for example, to get the student details and then the course the student is pursuing. And then after that, you can be able to get now the marks. All of those things need to be evaluated at each stage so that you can be able to tell whether that software is working or not. And then in the process of that testing itself, you need to be able to ensure that quality has been achieved, and then the cost is also something that can be managed, and also the time, the duration which is required is also something that you can manage. If you don't have those three aspects, then the testing itself will be of no use. So the reason why testing is normally carried out is because you need to be able to check the intended behavior of the software. You need you need to be able to check the intended behavior of the software. And when you are checking that intended behavior, you need also to be able to show the direction the software is moving. When we are looking at the direction of the progress is in terms of the stages that you had set in place. Are they being followed or not? So that the reason why we need to check on those aspects is to ensure that you avoid duplication of effort, you also avoid duplication of time and cost overruns. So when we are doing system testing and quality assurance, it comes in place in order to check for the system, and it will always include two aspects. This is important because if you don't have these two, then there is a problem. And these two aspects include, let me see if I can be able to type here. The two aspects of software testing and quality assurance will include the one is the product level quality and the process level quality. When we are looking at product level quality, basically we are testing the product to see if it has accomplished its functionality. So that goes without any question. We are looking at the product quality by testing it in terms of usability, testability. Those are things we will go through as we continue. When we are looking at the process level quality, we are just looking at how you are going through the testing process itself or the development process from the moment you are given the requirements up to the moment where you are delivering this software. So those are the two aspects which you look at. So the testing is the process or activity that will check the functionality and correctness of the software to a specified user requirement in order to improve the quality and reliability of the system. So that is what we mean by testing. And we will go through the different types of testing, the different characteristics of testing, and the different strategies that are normally used in testing. We will also look at the different types of testing, moving from unit testing, integration testing, functional testing. All of those are different types of testing we will go through. And then once we are through with that, then we can come to the quality assurance. And when we are looking at quality assurance, we are basically talking about the review of the system or the software product and its documentation so that we can be assured that the system meets the required specifications. And when we are looking at quality assurance, we want to provide confidence to customers that the system they are buying or the system which is being delivered to them is of the required standards. Also, it will include techniques that will ensure that procedures and tools applied by the software professionals are to the required standards. So when we come to this introduction we are sharing here, and we are talking about quality, why exactly are we talking about quality? One is because all over, even from history, people are looking for software or are looking for quality. And when we are talking about quality, what exactly do we mean? Quality is that aspect, like we will just see it right now, is that aspect of the goodness of a product or a service or whatever it is. That is why we are saying that traditionally there have been efforts which have been put in place to ensure that what the end product that is being produced is going to have correctness and it is going to be free of defects. That is why we look at quality. So globally, that is how we look at quality. And the reason why we are looking at it, first of all, is because of global competition. Why? Because whenever you are producing a software, you are not the only developer in the market. There are others as well. So if you are not able to beat their competition, then you will be out of business. There are other concepts like outsourcing. Even if a client is in Kenya, they can outsource for a product from the US, from India, from China. Why should they choose you? Offshoring. Right now we are talking about cloud computing and cloud services. Why should they invest in you when they can go for these other solutions? And then the increasing customer expectations, whereby a customer knows what they want. It is no longer the aspect of the developer knowing what the customer wants or developing a product and then delivering it to the customer. No, right now it is the aspect of the customer giving you what they want and then you develop that. So that is why we are talking about quality. That is why this unit is important for us to understand what quality is all about. So quality has many definitions and many understandings depending on where you're coming from. Quality can be fitness for purpose. So if you're producing a software that is fitting for a specific purpose, then it can be said to have quality because it is able to serve that particular purpose. Number two, quality can be conformance to requirements. Like we have said, the customer nowadays is somebody who knows what they want. So as they know what they want, then they can always tell you what their requirement is. And when that product or software you have produced fits their requirements, then it can be said of it is of quality. Also, a quality, if a product costs more to produce, give an example of a car, give an example of a phone or these electronic gadgets we are using. If it has more cost of production, it can be assumed that it is of quality because the more the cost, the more the price you will have to pay for that product. And it means that the more the cost, the more the quality. Number four is that quality is also the price that the consumers are willing to pay for a product or a service. So like now, if we are transferring money through M-Pesa and somebody is willing to be charged maybe 100 shillings to send some amount of money, then they can say that is the quality they are looking for. They don't want to give somebody or to send through any other means. If it is a product or a software which they are paying for. Give an example, an editing software. There are those which are free on the internet, there are those which are paid for. And maybe somebody is looking for a specific quality, and when they pay for it, that is what they are willing to pay for it, then it can be said to have that level of quality. Also, a quality can be perceived as compliance to the best known standards, processes, and specifications, especially if we are talking about financial software. Financial institutions have specific standards, like does it have maybe a username and a password? This software product you are selling, maybe it is for transferring money. Can anybody just access it? So if it is a software you are building, there are those standards which it is expected to meet. And if it doesn't meet those standards, then it cannot be said to have quality. So quality will be maybe checked against those standards. Does it have a username and a password? Does it have a one-time password? Does it have a verification, maybe using the lens of the eye or the finger scan, something like that? So if it has those standards and specifications, then it can be said to be of quality. Also, quality is value for price. What am I paying for? If I'm paying 1,000 shillings and it is able to deliver the value I am looking for, then I can say that software is of quality. Quality can also be considered as a satisfying experience. If you buy a software, maybe it is a music listening software and you are able to do your mixes and all of that, and it is satisfying you, then you can easily say that that product is of a software. So it is of quality. So quality can be perceived in all these perspectives or in all these point of point of views, because quality is perceived differently depending on what the customer or the user wants. Then we move on. When we are looking at the software processes which are normally used, then we need to understand that an effective quality process will always focus on the following. First of all, it is the customer's requirements. It will also make efforts to continually improve the quality. It will also integrate measurement processes so that you can be able to know where the product design has reached and the development. A process that is able to push the quality concept down to the lowest level of the organization is also said to be good, because it is at the lowest level of the organization where the development is taking place. Also, pushing the quality concept down to the lowest, making sure that the system level perspective is on the emphasis of the methodology and the process, then that is also an effective quality process. Also, eliminating waste through continuous improvement is also a quality process. So those are the aspects which are normally considered when looking at a good or an effective quality process when we shall be looking at quality assurance and system testing. So where did this quality movement start? Now, there is a book which I will share with you. It has more details, and it is the context that we are using. And the quality movement was started in Japan in the 1940s and 50s by guys like William Edwards Deming, Joseph M. Duran, and Koru Ishikawa. These are the people who started the aspect of checking on quality movement. They used statistical quality control, whereby it is based on measurements and statistics. Also, decisions were made and plans were developed based on the collection and evaluation of actual data in order to tell whether quality was achieved or not. And here we are looking at the quality of the product and also the quality of the process of coming up with that product. And so the software quality control metrics or methods were used in those times, and they involved 7 basic quality management tools, like the Pareto analysis. There was also the cause and effect diagram, the flow chart, the trend chart, histogram, scatter diagram, and a control chart. And most of these are still in use up to the present day. So when you read through the history, you will see how these diagrams were normally used. So in the 1950, William Deming introduced the PDCA cycle, or the Plan, Check, Act tool, which he called Schuhart cycle. And this one is normally used to illustrate the activity sequence, whereby you have to set goals when you want to provide a solution or to develop a system. You have to set the goals, then assign them measurable milestones. Then once you have assigned measurable milestone, you assess progress of those milestones. And that way you can be able to plan, do, check, and then act once you have assessed. And this is the Schuhart cycle, which was implemented by Deming in 1950s, whereby there is the process of planning where you establish the objective and process to deliver the results. Then in doing, you're implementing that plan which you have established, and you're going to measure performance during the execution. Then you are going to check, and this involves the assessment of these measurements. And once you assess them, you report the results to decision makers. And then in acting, you are deciding on the changes that need to be made in order to improve that process all over. Because, like we will see, there are many different development processes, different methodologies which are normally used for developing softwares and testing them. And you need to get the best depending on which software you are developing and what is your objective. So in 2004, Koru Ishikawa, who is one of the fathers of total quality control in Japan, outlined the following key elements which are normally used in quality control. One is that quality comes first and it is not for short-term profit. Number two is that the customer comes first and not the producer. Number three is that decisions are based on facts and data. Number four, management is participatory and respectful of all employees. And this we will see how it affects the whole thing. And then management is driven by cross-functional committees covering product planning, designing, purchasing, manufacturing, sales and marketing, and distribution. So that quality circle or these management elements are the ones which came up with a quality circle. And this quality circle would normally meet to discuss the problems that are encountered, and then come up with ways in order to overcome those problems. So one of the innovative quality methodologies developed in Japan was referred to as the Ishikawa or cause and effect diagram. Out of those quality management methods or elements, we had the cause and effect diagram, which was also developed by Koru Ishikawa. That is why it is called the Ishikawa diagram. And it had the 4 M's, whereby we have the materials, machines, methods, and measurements. Now, this is how they are normally used. When you provide materials and the machines, these are going to be worked on using methods, and those methods need to be measured, and these 4 M's are the ones which make up the causes. Then quality will be affected by these 4 M's. That is why we have the cause and effect diagram. So effect is the quality. If you have the right materials and then the right machines, and when we are talking about machines, here we are even looking at the human factor. So we have the right elements, then it would be very easy. It will be very easy to have the best quality which you require. So that is how the cause and effect diagram normally works, whereby we have the materials, the machines, the methods, and measurements. And these four are the ones which are going to give us the best result. Yes, Marie?
I am asking about the cause effect diagram.
Yes.
Are we supposed to cram the way it looks? Is it examinable? Just the way it
Yes,
is?
yes, it is. It is
Uh-huh.
examinable, and you need to understand it, because this is actually one of the bases which we shall be using as we continue.
Mm-hmm.
When you are looking at the materials, the machines, the methods, the
Yes.
4 M's basically, those are the
Mm-hmm.
ones which will affect the quality of the product that you are going to get at the end of the day.
Okay, thank you.
Okay. Let us proceed. So after understanding that aspect of cause and effect, then we look at software quality, because this is very specific. Again, software quality is also perceived from different angles, or it is understood from different areas. So in different domains such as philosophy, economics, marketing, and management, you will find that there are different definitions of quality or software quality. One of the definitions is the transcendental view. And when we are looking at the transcendental view of quality, it means that quality is something, quality is something that can be recognized, but it is difficult to define. That is what is meant by transcendental view. It is something that you can, you know, you need it, you know, it helps you, you know, it is of great value, but you cannot explain it. Now, somebody gave an example whereby they said that a transcendental view could be compared to when somebody is in love. You know you love this person and you know you can live without, you can't live without them, but you cannot explain what is it that they affect you with. So that is what is meant by a transcendental view. Something that you know is very important, but you cannot explain. There is also the user view, whereby quality, the software quality is perceived as fitness for purpose. If the software product is able to satisfy user needs and expectations, then it is viewed as of quality. Then we also have another definition, which is manufacturing view. And here, quality is being viewed as conformance to the specification. Like we had said, there are those standards, especially when you are looking at financial software or security or what we call high dependability software, whereby if it went down, so much is at stake. So there are standards which are normally put in place to ensure that this software has to conform to those standards, and if it doesn't, then there will be a problem. So that is what is meant by the manufacturing view of software quality, whereby it is conforming to some standard or some specifications. Then we also have the product view, and when we are looking at the product view in terms of software quality, is whereby this quality is tied or is connected to the underlying characteristics of the product. That is like the internal design. When we are looking at these mobile phones, which are being manufactured every day, these smartphones, you can hear about the speed of the mobile device. You can hear about maybe the storage, the camera. Those are the inherent characteristics or the underlying characteristics which will ensure that this product looks more of quality as compared to others which are in the market. That is why we look at it as a product view of quality. And then there is the value-based view, whereby in this perspective, it looks at quality is being viewed from what the customer is willing to pay. So you could be having so many other products out there in the market, but if the customer is willing to pay whatever amount to be able to have this product, then we call it the value-based view of that product. Some of these designs, like you can see an iPhone which is made of gold, and somebody is willing to pay for that gold-based iPhone because it is of value to them. As much as it is being used basically for calling and connecting and communicating, they are looking for that something extra, which they are willing to pay for so that they appear unique. And that is what is called the value-based view of software quality. So that concept of software quality is normally summarized in these two areas. One of them is what we call the quality factor, and the other one is a quality criterion. So this guy, McCall, Richards, and Walters were the first to study this concept of software quality. And when they were looking at software quality factor, they were looking at the behavioral characteristics of a system. Things like correctness, is it doing what it is supposed to do correctly? Reliability, efficiency, testability, maintainability, and reusability. So those are the factors they are looking at in order to say that this software is of quality. Those are the behavioral characteristics which are supposed to define quality according to them. Then there is also quality criterion, whereby criterion will be an attribute of a quality factor. Like for example, when we are looking at reliability, reliability can have an attribute like modularity, meaning that in the software design or in the architecture of the software, it is very easy to break down this software into several modules which are going to be able to work independently of each other so that they can give the performance that is required. So when we are looking at quality criterion, it will be under quality factors. So if we can look at a quality factor like correctness, it can also be applied with modularity in that each module is working correctly. So that is how they are normally used together. Then, after looking at those two factors which are normally used, then we look at the quality characteristics which are normally used. But these quality characteristics will be based on the ISO standards and also the capability maturity model. So what I will do is stop here because these are two standards we will look into detail as we continue in our later classes. So I would like to end it there, and we shall pick up from there next week so that we can start understanding these quality metrics. So any question up to there? Yes.
Are you going to share the notes?
Yes, I will be sharing the notes at the end of each class. So what I am asking is that you also give me your email addresses, or I will get your email addresses from the quiz that you will be doing. I collect the email addresses from the quiz so that I can be able to send you the notes.
Okay.
Yes. So I will be sharing it, and then I will be sharing after I have gotten your email addresses. And then I will also share the link for the quiz, which should be done by 6 today. So at the end of each class, we shall be having a lecture quiz that should be submitted at the end of each day. And the reason,
Only
like I, yes,
only one.
yes, it is just a chapter quiz which has several questions. It is out of 10, and it is multiple choice based, with one answer where you need to type some few answers. The reason for this is because I would like everybody to participate. Even if somebody has not attended the class, I'm going to share this recording on YouTube so that people can follow it. But at the same time,